Good evening, everybody. Welcome to tonight's edition of the Triangle Area SQL Server User Group's main meeting. We are on a very strange Tuesday in that it's actually a Wednesday, but because it's Wednesday, we were able to get Andy to talk to us about Plan Explorer utilization. So instead of me spend a lot of time talking, let me just hand it right over to Andy to take over.
All right, thank you for that introduction, and thank you all for having me tonight. I'm super excited to be giving you this presentation about Advanced Plan Explorer usage for tuning execution plans. So here's my biographical information, just a little bit of info about me. Really the only important things on here is the fact that, I've been a DBA and a DB developer for a long time, been working with SQL Server for quite a while, and I'm also very active in the community. So I don't blog as much as I used to, but I speak a lot, I present a lot. I'm fairly active in the Chicago general region and that sort of thing. I'm also moderately active on Twitter, and I love to talk to people. So you see my email address, you see my Twitter handle up there. I love to talk to folks, and if you have feedback or other questions for me after this presentation, please don't hesitate to reach on out. All right, but enough of that. Okay, so before we get in this presentation about Plan Explorer, there is one thing I want to address, and I like to think of it as the elephant in the room. Plan Explorer is made by SentryOne. I am also an employee of SentryOne. So here's the thing. What I want to reassure everyone is that this is not a vendor session. This is not a sales or marketing session or any kind of nonsense like that. I developed this purely as a community session because before I was an employee of SentryOne 3 years ago, I've been a community speaker for many, many years prior to that. And I've also been a big fan of Plan Explorer long before I joined the company. So really my goal is to really just, develop or, present this as a community session. I'm not even here to try and convince you to use Plan Explorer. My ideal audience members are people who already use Plan Explorer. So again, my promise to you, no sales, no marketing about paid products or any other things like that. So, with that, let's go on. Okay, so I also want to be clear about today's goal and today's agenda. So, again, this is all about Plan Explorer. And really, I want to, showcase things about Plan Explorer to help you really speed your use within Plan Explorer. Because I find that a lot of people that I talk to, are only using Plan Explorer on its surface level. They're not really diving in much deeper. And it's a very rich and dense tool, and there's a lot of really cool stuff. I mean, there's stuff, heck, I didn't even discover until after I started working for the company and had to learn it on an even deeper basis. So, again, that's today's goal. I will say that this presentation is almost entirely demo. There are some slides initially up front, mostly because I can't demo that, and you'll kind of understand why once I get to that. And I want to be very clear. I'm not going to be covering basics because I expect to be you, or my ideal audience members, to be users of Plan Explorer today. Again, I'm not here to convince you of it, to try and use it. I want you to be using it already. Otherwise you will be left in the dust. So I want to warn you about that now. Also, I also want to be very clear. This is not necessarily like an execution plan query tuning session. This is a usability session about Plan Explorer for tuning your execution plans and your queries and such. But I'm not teaching you necessarily how to tune your queries. So I want to be very clear about that agenda piece as well. Now, for what it's worth, if you are still hanging out here and maybe you're still more of a novice user of Plan Explorer, you want to learn more of the basics and stuff like that, here's a whole list of resources for you. I don't necessarily expect you to take a screenshot of this right now, but I do want you to at least remember my GitHub address, that github.com/SQLBeck, which is my online alias. Every single presentation I do has an individual repo up on my GitHub, including this one, of course, and this is where you can get that resources slide. So as you can see, there's tons of information, tons of resources out there to help get you up to speed as far as basic Plan Explorer utilization is concerned. Okay? All right. So with that, one of the questions I commonly get about Plan Explorer is, why should I even be using Plan Explorer when we have Management Studio? And I want to present you with this particular quote. I think there are two steps to the evolution of a query: ensuring correct results and performance optimization. This quote is by my good friend and colleague, Aaron Bertrand. And he actually used to be the program manager for Plan Explorer, amongst other things, during his tenure at SentryOne. And I really like this quote a lot because, the first half of it, the ensuring correct results, is really the role and purview of Management Studio. Whereas once you know that a query is returning the right data and such, leverage Plan Explorer beyond just glancing at a given execution plan, but think of it more as a development environment or a perf tuning environment. And I'm going to show you a few things to hopefully, again, help you shift your mindset so that you can, once you're starting to work with an execution plan or a set of code, that you can stay in Plan Explorer rather than necessarily having to bounce back and forth all the time, right? So think about this as we're kind of going through this, this process and, the different things I'm going to be showing you. All right, so first chapter, if you will, is going to be all about customizing the user interface for Plan Explorer. Now, of course, in today's day and age, a lot of us are stuck working on laptops, right? Many of us didn't have the option of bringing any hardware home. So, we're stuck with just this tiny little screen, right? And, as I kind of mentioned before, as we all should know, Plan Explorer is a very information-dense tool. There's a lot of things going on. So there's a lot of different windows, a lot of different tabs. So if I want to see something or more details within something like index analysis down here at the bottom, obviously if I move that up, I now have to sacrifice something else. Like for example, we now squish down the plan diagram. So that's now a lot harder to see, right? But here's the thing, as we've all been stuck at home as the months go by, some of us have gone out and invested in additional hardware and now have multiple monitors, as I've done so here. And did you realize that you can actually drag and drop the various tabs and or windows and dump them into other monitors? So make use of that extended real estate rather than just being trapped in that one window. I find it's one of those like, oh yeah, I didn't realize I could do that. It's so simple, but hey, it makes absolute sense. So if I were to expand this out, what we were seeing before, now you see what I've essentially done is, I'm simulating here what, this would look like in two monitors. On the left-hand side, you have most of the typical tabs, but on the right-hand side, I decided to put the entire plan diagram, just so I can have my entire execution plan all in one, one monitor all to itself. Or here's a different variation where I've moved some of the other tabs on over, like the query columns tab and the index analysis tab. That's now on one monitor, whereas now I have the plan XML and the plan diagram, plan tree, and the statements tab all in another section on the other monitor. But again, imagine this in two massive monitors on my desk. I'd be able to see all of this information. Leverage that additional screen real estate is kind of the takeaway. So with that, let's dive into Plan Explorer itself, and I'll kind of show you some of the cool ways that you can actually adjust and make modifications to your user interface. Okay, so let's see. Yeah, so everything's coming through fine. So this is the default layout of things, and you can grab not only I can grab up top, so I can grab like an entire window section, or I can grab individual tabs down here as well and move them about. So for example, maybe I'm going to grab query columns. I'm going to grab this tab down here. And notice I have a number of different options if I move to the middle section here, or if I move up here, and then let me zoom in here. So now I'm, highlighting in the middle section. Notice that I can move, and stack this on the right side or to the left side, or I can add this as a tabbed element now in the middle section here. So let me do that now. I'm going to stack it on the right-hand side. So this way now I can see I have text data, I have query columns, and then let's say I want to bring in something else with query columns and bring them now as a tabbed element. So if I zoom in a little bit, you see how I have that that option here because I've dragged it over here. I'm going to dump it here, and then it'll show up down here as a secondary tabbed element. 1, 2, 3. And there we go. So now I can jump between expressions and query columns, for example. I can even take things to the next level, and let's say I'm going to grab top operations. And you know what? I'm going to pin it all the way over to the right-hand side. So now it's actually another column over here, for example. So there's a lot of crazy things that I can do as far as, stacking these different things and playing around with my different layouts, right? I could even just pop out a window entirely if I wanted to. Maybe I just want to have the plan diagram floating in the middle of, in the middle of my screen rather than having it docked to something. So Now, here's the thing. After a while, maybe you really messed around with stuff and you're like, wow, I just want to get back to the default layout. So unfortunately, there's not a good way to do this in the application. What you really need to do is close everything out and go to, actually, I used to have this out. Sorry. So basically, you're going to be going to your user data and then app data, local, and SentryOne Plan Explorer. Let me at least zoom in on this. I have the URL buried in. It's up on my GitHub. There's a README file, and that has it in there. I forgot to have the README file open for you guys already. That's typically what I do, just so that you can see the URL. But in either case, that README file on my GitHub has the shortcut URL to it. But in either case, you see there's XML files, and then there's a layouts folder here. So each of these, and then inside the layouts folder, there's also additional XML files. All of these contain different attributes and data and information about all the different customizations you've made. Frankly, I don't know which one contains what, so I blow them all away to completely reset everything to stock. And that suits my purposes. So I've blown them all away, and then the next time I open up Plan Explorer, everything will come back. So let me go back to my demo things, go to open up my PE session file that we happen to have. And here we go. We're back to the stock look and feel of Plan Explorer. Now what I'd like to do is at least just mention how I like to make changes. So for me, I don't really care about seeing text in and Plan XML in the middle, and all of the different tabs along the bottom I think are very, very useful, but I also like to drag the plan diagram, and I like to add that as a tab here in the middle, because usually I like to see the plan diagram at all times or most times, and then that way I can shift through the bottom tabs as well, like plan tree or top operations, and then I can also have the results and statements tab available to me up here as well. As I select different statements and that sort of thing, I can visually see the plan diagram update, and I can also see how top operations moves around as well. Sometimes if I'm doing a lot of heavy work, I will drag index analysis out and put that in its own window, because index analysis is an extremely dense, information dense and real estate needing tab in of itself. So that's usually what I also prefer to do as well. Okay, so that's all about windows and tabs, but a second layer of customization has to do with all of the different data points we have available to you. So first of all, I'm going to go up to the results in the statements area, and actually, we have information on duration, CPU, reads, writes, and all that kind of good stuff. What a lot of people don't necessarily do is they don't necessarily scroll to the right and appreciate some of the dynamic columns that will appear. And let me expand some of these, and then I'll zoom in here. So these different dynamic columns will show up if you have one or more statements that where that element applies, or that element appears, I should say, in the given execution plan. Like, for example, if the query optimizer generates any missing index recommendations, like here and here, this column will now appear. Or how many table scan operations do I happen to have all throughout? Or key lookups. Or this one is missing join predicates. We never want to see any of those, right? But obviously I have at least one statement in here that has a missing join predicate. Otherwise, this column would not be present. So always scroll to the right to see if there's any interesting things that pop on up. One of my favorites is a combination of key lookups and missing index recommendations, because oftentimes when I see that, that is often indicative to me of low-hanging fruit. And we'll kind of talk about that example a little bit later. Also know that you can right-click and go to something called the column chooser, and that will invoke a an additional menu up here where you can drag in a whole bunch of other data points that we don't manifest by default. Some of these are more useful than others. Some of these are more esoteric in my personal opinion. But you know what? It's kind of cool that that you have these here. So for example, like maybe you're doing something around merge joins, I don't know, or you're trying to hunt around for them. Or one of the ones that I kind of find useful sometimes is hey, do I happen to have a lot of spool operations, right? Because sometimes, we have those statements that are using tempdb in a way I don't necessarily expect. So I might drag that in there if I want to kind of dig in a little bit deeper. Maybe I'm going through a whole bunch of different statements. So I just want to see that summary information. So keep that in mind. Now, we have that up there for the results tab in the statements area, but also come down to both top operations and the plan tree. So I'm going to do this in top operations right now. I'll open up the column chooser, and now inside top operation, there's a whole slew of other data points, really, really detailed type information that, frankly, a lot of us won't necessarily use. But I mean, if you're really deep diving into your execution plans and whatnot, some of these are things you may want to know about. So, drag these in and include these as well. So, there's plan tree and top operations have slightly different subsets of columns. Frankly, I don't know why. That's actually something I've asked product to fix too, because they're fundamentally the same thing. But in either case, you see, as you read down the list, some of the different, pieces of information that are available to you. These are all things that are buried deep within the plan XML. So if you really wanted to look at the plan XML, you could. Or you could just drag the column here, because again, it's one of those things of convenience. If you need these specific points of information, they are available to you. Right click, pop open the column chooser, and kind of dig in deeper and see what's available to you. Because again, some of these things, depending on your level of execution plan knowledge, may be useful to you. All right, so there's that. Let me see what we're going to be talking about next. So we covered that. Yes, I'm working off a cheat sheet. I'll be perfectly honest. This is one of those presentations where I have so much going on, and I've changed so much of it recently that yes, I am still using a cheat sheet. So let's see. We've covered that. We've covered that. We've covered that. Oh yeah, this is one random tip that I'm going to move my photo for. So up here, duration and these time units. What are these time units in? I can never remember. Is it milliseconds or is it microseconds, right? So let's see. I have this one selected here. So whenever I have that selected, go down to the bottom. Oh, this is being a little weird with the picture-in-picture. Hang on. Come on. This is so meta. Anyway, down here is where you can actually see the time as it is translated into a human readable time. So I can see that, oh, this is actually in milliseconds rather than microseconds, right? So check that out. It's one of those things that I always overlooked, but again, I wanted to kind of convey that as a quick little tip, because again, it was one of those things that got me after a while. So double check that one. Also note that we, especially nowadays with SQL Server 2019, and many of us, bringing in databases from, older versions of SQL Server by having to use older compatibility levels and that sort of thing. And how the cardinality estimator changed, a couple of versions back. Sometimes it's actually important to know what CE we are running in. So again, another piece of convenient information. Double check that one down there. Okay.
So we have a question, Andy.
Oh yeah, go ahead.
Can you show how to get to that menu option again?
Absolutely. So anywhere there's a data grid, so right now I'm just hovering over estimated rows, for example, just mouse on the column header itself, right click, and go to column chooser. So I'll zoom in on that. So, I just moused over one of these guys right here, right clicked, and you see that there's a whole bunch of different options, and it's column chooser that I clicked on. So I apologize if I went a little fast over that. I am notorious for going fast.
Right,
Any other questions at this point?
That was the only question so far, but anybody who does have questions, actually, is the Azure Data Studio version similar to the standalone app?
Great question. So I'll be perfectly honest. The Azure Data Studio version there's a reason why we still call it a beta version, because frankly, it only has a small subset of the functionality that Plan Explorer standalone happens to have. So it's definitely not a one-to-one substitute. Long term, we would love to make it a one-to-one substitute, but we haven't seen the adoption, so it hasn't necessarily justified the engineering resources at this point. So.
All right. Thank you.
Of course. Okay, so with that, what I want to kind of talk about is how, let's see, actually we'll do this demo next. While I'm talking about the different columns and whatnot, one thing I want to point out, whenever I mouse over any of the column headers, this teeny tiny little icon will pop up. And this is actually a little filter icon. I really, really wish they would make this bigger. It's one of those things that a lot of people oftentimes overlook. But this allows me to now filter on this column. We will show you a discrete list of every single possible value, so I could do it, this way and just be lazy and just, select one of these, or I can do a custom filter of some sort. So, I can choose statement, but there's all these other different data points that I can select if I wanted to as well. And then instead of just doing equality, I can do a is equal or does not equal or contains or various other things like that. So for something like this, I might do a exec. So, oh wait, no, that's not for that one. Actually, I thought that one that worked that way. Of course. In either case, typically you can do a is it a statement or text data? I think it was under statement. Well, in either case, there is typically a way that you can search on text in here as well. Wow, this actually differs from. Anyway, sorry. This behavior actually slightly differs from the standalone product. So, yeah, I learned something new today. That's kind of funny. Again, there's so many nuances between this, but anyway, sorry, I don't want to get into a tangent. But typically, you can filter and whatnot on non-zero values or other text-based values and things of that nature. So play around with that, see what works, see what doesn't, as I obviously just surprised myself with. But in either case, make use of those different filtering capabilities, right? And for what it's worth, actually, let me do a filter here. So I'll do reads. That'll be let's see. Let me do this. Reads is greater than 0 because I want to illustrate 2 points here. So first of all, I have reads greater than 0 here, right? And one of the things is that whenever I'm looking at a data grid, the filter that you've created will be manifest down here. But there are times that the filter will remain, but I'll start working on something else and I'll forget to blow away the filter. So there have been times where I'm looking at a results set in a data grid. I'm like, wait, where's half the records that I expect to be seeing? Oh yeah, I forgot I have a filter down here. So always draw your eye down there, because again, that's one of those things that's kind of a little bit of a gotcha. It's definitely burned me plenty of times. So let's see if there's a good example of what I wanted to show next.
So while you're looking at that, we did have another question come in. How does Plan Explorer differ from the Plan Explorer within the SentryOne SQL monitoring solution?
So okay, so how does it differ? Fundamentally, it shouldn't differ at all. Obviously, I found one little quirk, but the standalone Plan Explorer is fully baked into the paid product as well. So so fundamentally, they are the same. Like I said, I found one little behavioral quirk, but that should not be there. So that's probably a bug. So yeah, no difference.
Great, thank you.
Yep. Sorry, I promised not to talk about the paid product, but I was asked about it, so I plead I plead innocent. Sorry, teasing. One thing that's interesting about this, and I kind of want to point this out, is that most people, when they're looking at Plan Explorers, because they executed the query inside Management Studio, and then they brought the execution plan into Plan Explorer, and as a result, your statement's result looks different. It's flattened, right? But here's the thing. If you noticed, I was looking at a different version where things were not flattened. So if I go to my history tab and go over here, you see I actually have the call stack and different elements that actually executed this, each given piece of code. So this is just a store procedure that executes a whole bunch of other store procedures to kind of illustrate this point. Because one of the cool things that you can do in Plan Explorer, and this is kind of my point earlier about, going back to that quote about using Plan Explorer as a development environment, is that you have this command text tab up here. If I go to this is what actually has the underlying T-SQL that you originally executed. Now, typically when people are using the standalone Plan Explorer, you copy and paste the execution plan in over here, so this will be empty. So that's why everything will look like this. So I'm going to go to version 1 in the history. And by the way, the comments is showing me that this is where I ran the code in Management Studio and opened up the actual execution plan results in PE. So as a result, the command text window is completely empty. So in this case, I have to copy over the T-SQL, but then once I've copied over the T-SQL, which is this store procedure, and then I click on get actual plan, I'm rerunning the query inside Plan Explorer. But because we're doing that, we're able to pick up a whole slew of other information, including the full call stack here. And we're also able to pick up other statements that effectively don't do any work, like these drop table statements, for example. So there's other elements that will be picked up that are, again, are not present in in what most people are used to seeing. So this is where I encourage you guys to start using the command text here, and if you can, use get actual plan. Of course, be very careful in your production environments, but if you have that capability, or again, if you're doing cyclical development or perf tuning development in your dev environments or QA or staging environments, make use of this functionality so that you can get a better sense of the bigger picture and everything that's going on here. Okay. And also from a navigation perspective, now that I'm looking at the full call stack, I can right click on this parent guy up here, and now I have the abilities to expand the subtree or collapse or whatever the case may be. So I'm going to collapse all, and now you see that when I expand, okay, so I'll fully admit that this is yet another bug that I've encountered from time to time. I don't know why this is the case, so I actually have to restart. I hate it when this one bites me. Yay for live sessions where things go wrong. But honestly, we're real software, and real software has bugs. So anyway, so I minimize that and I re-expand that. Or whoops, I want to collapse all. There we go. And then I'll expand this out. So now you can see how essentially, we have individual statements that occurred inside the store procedure, and then there are other store procedures here. Whoops, there are other store procedures here that are collapsed right now, and then I can collapse or expand them. But what's nice is that you can see the summary information as well. Am I really worried about some of the statements inside the store procedure, or no, this store procedure, like this guy up here, for example, didn't do all that much work, so I can skip over that noise, collapse it down, and really only focus on the other elements. And I can sort this way to, again, better, again, this is all about speed of getting to the pieces of information or the statements that are problematic for you, especially when you have that very complex call stack. So make use of that and understand that there's that nuanced difference if you start executing your code and getting that full call stack inside Plan Explorer. All right. So let's see. Oh yeah, and here's a simple little silly example of things. So I'm going to come back over to the command text window, and I'm actually just going to dump in this simple select star from sys databases just to demonstrate all this. So we execute this guy, and as an example of how we get more information from behind the scenes, if you guys are familiar with SQL Server statistics, what are all these select statman stuff? That's basically SQL Server having to, basically re-update stats and stuff behind the scenes. And now I see that that's actually occurred because I haven't run select star from sys databases, since I rebooted my machine or for whatever period of time it was. In either case, again, we see these other things that are kind of hidden behind the scenes here when you actually run things inside Plan Explorer. So it's kind of one of those cool little, oh, hey, we have that extra bit of information. And then this is an example where you can leverage the history. Hey, I don't want to deal with the sys databases guy over here, so I'm going to go back here and go select, the second item in the history element, and now I'm back to that workload data set with all, all my different statements and that sort of thing. So it's very easy to bounce back and forth, and that's the other advantage of using this as a development environment for your perf tuning, because oftentimes perf tuning is an iterative process. I might make an index change, I might change around this join or this predicate. Let's see how this thing changes. Oh, this really is terrible, I have to go back a couple. We all do this in Management Studio generally by making copies of our code and stuff like that, but sometimes it's useful to go back and then see what the execution plan was and what the underlying IO was and all that other metadata information that we can't really necessarily do in Management Studio unless you are copying and pasting all those data points out, sticking them in comments and that sort of thing. We save you the headache of doing that if you do that all in here. All right. So with that, let's talk about more of a specific use case and how you can leverage Plan Explorer to dive into those things. Actually, this is a good time for me to pause and see if there's any questions from that usability kind of chapter that we just concluded. And get a drink of water.
Yeah, so there's a question. Can we pull the plant data from Plan Explorer from a live stream or live system?
Can we pull? No, not without the paid product. So no. And also, I mean, from a live system, you basically would have to go into the plan cache itself and then grab the plan and then dump it into here, because you can't, because we can open plan XML straight up as opposed to just running the command text if you wanted to. But no, we cannot magically, like in stream, like maybe you have that statement that's been running for 4 hours. We can't just suddenly start pointing at it and magically pick up, and start monitoring it that way. And you can't do that in the paid product either. So sorry. Any other questions?
One question that I'll hold to the end because it's a little interesting topic, but doesn't quite fit in here. So
Okay,
no other
well,
questions
ask
at
the
moment.
question anyway, and if I agree with you, then we'll come back to it. But I'm kind of curious because in case it's one of those, well, actually, I answered this in X demo or something like that.
Probably not. So the question is how Plan Explorer compares to Apex SQL's plan tool.
I cannot answer that question, and I'm not going to answer that question, especially on record. And we'll just leave it at that. Especially since I'm obviously a biased employee. So and you'll have to ask someone else who's not biased about that. And
I
frankly,
can
I've
tell
never
you,
actually
you're
opened
wearing
it
the
up.
shirt.
So but yeah, that's fine. Any other questions at this time?
No questions.
All right, cool. So the first kind of common scenario that I kind of want to walk us through is parallelism and troubleshooting parallelism. A lot of us deal with parallelism. Sometimes it's good parallelism, sometimes it's bad parallelism, sometimes it's unexpected parallelism, right? So I want to show you how you can kind of do some really cool stuff and find information rapidly inside Plan Explorer. So I'm going to readjust 2 columns up here, but then I'm also going to open up the column chooser and pull in something else, and then I'll zoom in and I'll show you what what I'm doing here. Okay, so remember the summary columns I talked about, and there are 3 of them that are very useful for identifying parallelism. So obviously, degree of parallelism will tell me that how many cores did one of my statements happen to use. Parallel operations is also one of the default columns as well. And that differs very slightly from parallelism operations, which is one of the columns that I dragged in from the optional column chooser. So the first one, parallel operations are the number of operations in the execution plan that went parallel, like a scan, for example, as opposed to parallelism operations are physical operations that are related to parallelism, like a gather streams or something like that. So to kind of further reinforce that, what I'm going to do is I'm going to use my filter functionality here. I'm going to grab one of these guys. Let's see, I think this is a good example. Yes. So I selected parallelism operations. I used a filter and I just selected statements that have 3 parallelism operations. By the way, you might be wondering, let me address this, with the filter, I selected 3. So why do I have entries up here that are 0? That's because, remember, we show you the full call stack. So we're actually showing the parent store procedures as well. So it's basically it's just the way that we are materializing that information. If we were showing this all flat because you had just pulled this in from Management Studio, then you would not be seeing this behavior because we don't have that summary information that was not exposed to us in the Plan XML. All right, so what I'm going to do is now I'm going to expand this down here, and then I'll come down here. Okay, so remember we had 3 parallelism operations. So what I did is I'm opening up top operations down here. I resorted the operation column here, and you see that we have 3 parallelism operations. If you look at the actual plan diagram, they're gather streams and 2 repartition stream operations, but we prefix it just to really help identify that these are parallelism related operations. Now, the parallel operations are manifested or tagged, I should say, in this particular column over here. So this is where we're showing you that, yeah, these are the operators that went parallel in some way, shape, or form. So in addition to that, let's see. Sometimes when we go parallel, we've got to ask ourselves, is this good parallelism or bad parallelism? Did we really want to go parallel? And some of the things that we might look at is the cost the cost of the plan, or the estimated cost of the query, I should say, as opposed to our versus our cost social for parallelism. And then we also want to see whether this was perhaps unbalanced parallelism as well. So to answer that first question, I'm going to actually add in an optional column to top operations. So under column chooser, top operations, estimated total subtree cost. Let's see, I'll pop that one right here. So with the estimated total subtree cost, that's like the query bucks, as some people call it, other people call it farkles or whatever. So these are the actual units, and now I can see them on a per operator basis to quickly figure out which operation is like the the sum total. I just like to sort by estimated subquery cost percentage. And that way that'll draw me to the, give me the 100% guys. And then I look at the top valued one, because sometimes these are identical. Sometimes these are non-identical. In this case, they're just barely different, but 82.9, it's close enough. And this is the parallelism operation, which is the second to last operator here. And then here's the select into operator, because typically most people will just mouse over the select into in order to get this value here. And you can absolutely do that still. I can always mouse over the plan diagram in order to get that value. But again, I just wanted to show you how you can also drag that into here and see this here. Now, I'm going to jump over to the plan tree. The plan tree has a couple of extra columns that are not present in top operations. Like I said, I've asked product to normalize this in between them. But inside the plan tree, I now have the thread distribution information here. So thread 0 is that control thread, if you will, that, and then here's the number of records that are, as they are passed around in between different threads. So my VM is a 4 virtual core VM, hence why I happen to have 4 threads here. And now we can clearly see the number of records that were passed in between, or that were distributed in between them, right? And this is a case. Well, the parallelism distribution is fairly balanced. That's good. Imagine, or let's pretend, what if thread 1, instead of 3,300 records, got 33 million records, and the rest of them only got 3,000 some odd records. Well, now we know we have unbalanced parallelism here, right? This is a telltale sign of maybe a statistics issue or something else like that, right? So this is where I want to show you how you can get at that underlying information. So you can leverage that, or you can go back to top operations, and when judging that estimated total subtree cost, like this one, 82. A lot of people will say cost threshold for parallelism value between 5 and 50. Typically things under 50 you don't really want to go parallel. So you can use this value to judge, hey, should this guy have even gone parallel in the first place? So here's a different example of that. I think it's this guy down here. No, not that example. Was it this example? Yeah, this example up here. So this is a prior execution of a slightly different statement where my estimated subtree cost is 35, but I still had some parallelism operations here. So is that a guy that I really want to be going parallel or not? And assuming that you never adjusted cost threshold parallelism and you've left it at 5. So again, these are different things to think about when you're dealing with parallelism, but I want to show you again how to get at that underlying data rapidly, so that way you can kind of answer those questions quickly. Okay. Any questions about that little tidbit and that little segment while I conveniently drink some water?
The question that came in during this was if there's the ability to compare plans before and after.
So the way I would be comparing plans before and after is I would just be jumping between the history, but there's no direct way, kind of like side by side, to do kind of a plan comparison per se. But typically, like I said, my workflow would just be to jump between the history versions, because typically I'm going to be doing different iterations of things, so that way I can kind of see how things changed.
Makes sense.
Yep. Okay, so if there are no other questions, the next topic that I kind of want to talk about is parameter sniffing. Parameter sniffing is something that a lot of us combat on a regular basis as well. So I kind of want to showcase how you can leverage, some of the cool things. Or, sorry, is there a question?
No.
Okay, cool. Sorry, there was a bit of background. I wasn't sure if you were jumping in again. All right. Anyway, so yeah, how you can leverage Plan Explorer to kind of dig into parameter sniffing. So, okay, there might be some audio feedback. That might be what's going on. All right, so let me jump back to version 2. I need to be on this guy here. And then I want to scroll. So by the way, if I'm messing around with all the different sorting and whatnot, but I want to go back to the original sort, one of the other cool quick little tips is that if I right click here, I have reset sorting. frankly, I don't know what the difference is between reset and clear sorting. That's one that's always confused me. So I just use reset sorting. But again, if I've resorted by CPU or any of these other data points, I've messed around with the filters, I can just click on reset sorting to go back to the chronological order of, or the true execution order of things. So I'm going to do that real fast. And then the example that I want is conveniently down at the bottom. Okay, so let's see. I need to shrink this down a little bit just to make this a little more readable. And then, yes, and then, okay. So what we have here is a store procedure, and then we have some underlying code. I'm going to go to the text data. The text data is actually showing me the statement level text, right? So inside the text data here, what we have is a select statement that does some aggregates and so on and so forth. Fundamentally, basically what we're focusing on is the customer table, where we're narrowing down customers by state. And state, as you can see, is a variable, right? So again, we're talking about parameter sniffing, so you guys can probably see where I'm going with this, or it can kind of predict, what's going on here. So if I look at the execution metrics, we've executed this store procedure twice with two different state values, Alaska and Illinois. And of course, we can definitely see from the resource utilizations and the duration values that we have a problem here. 4.3 seconds versus a fourth of a second. Logical reads, for example, 41,000 versus 1.7 million. So we have a bit of a problem here. This is a classic case of parameter sniffing. So how can we see other elements or other details about this? Well, there is a parameters tab down here. So I have the first statement highlighted down here. And this parameters tab is now going to show me that, hey, I have this state parameter. What was the execution plan compiled with? And then what was my runtime value? So if I select the second execution of this guy, notice that the runtime value is now Illinois. And I can see, oh, hey, that definitely differs from the compile value of Alaska. So sometimes just having that bit of extra information to know that, oh, I compile with a bad data point here, can definitely help you on out. But another way to visually quickly see, because like maybe, with states, maybe we know our data well enough. We know that there's data skew here, but maybe it's something more esoteric and we have no idea of the data's distribution. Maybe it's like order date or transaction date or things like that, where we have no idea of the data volume. One other cool little tip and trick that I want to encourage you guys to use is this button up here, Show Estimated Plan. I don't know about you guys, but in all of the different tools and applications I use, like MS Word, Excel, there's all sorts of buttons and stuff like that in the tooltip or toolbar and whatnot that I've never even touched. I don't even know what the heck they do. I've never even bothered really looking at them. And this is kind of one of those that for the longest time, I never really bothered looking at this. I saw it was there, but I just kind of glossed over it. But when I really discovered it, I'm like, this is actually kind of powerful. The reason being is this. Right now, we're looking at an actual plan, right? And there are many different ways to see if you have difference between actual and estimate, actual and your estimated by looking at estimated rows versus actual rows and whatnot. But this is another way to look at it, is that I can quickly visually click on this, and now we're going to overlay the estimated plan. And then I click on it and I see the actual numbers behind it. So if I'm clicking back and forth, I can see different changes. So for example, let me zoom in here. You see the underlying values of what was coming out of the customer clustered index scan, like 76 records here, for example. That's my estimated. My actual is a whole heck of a lot higher than that. But I'm not necessarily going to, if I have that ginormous execution plan, I'm not necessarily going to be looking at the underlying numbers. But usually what'll jump out of you are the things like the line thicknesses, or maybe some of the colors will change. Highlighting different operators as what was the most expensive operators from the estimated plan versus what wound up being the most expensive from the actual plan. So again, just sometimes those color coding changes will immediately visually pop out to you like, oh, I'm going to want to look at this because these two things definitely look different, right? Or there's definitely a difference here. So just toggling this can oftentimes be very, very useful to quickly visually see. Again, you can always look at the data grid as well, but there's many different, my point is that there's many different ways to kind of attack this problem and see that there is a major difference between the estimated and the actual, in this case due to parameter sniffing, right? So in this, so let's see. So with parameter sniffing, oftentimes it's a result of data distribution issues and like statistics and things like that. So, sometimes we'll have to go into the database and query the data. Maybe we'll do some count aggregations just to kind of get a quick idea of things. But in Plan Explorer, if you've run everything inside the command text, you can just go straight to index analysis. And inside index analysis, which is completely unique to us. Let me move my little window up here. You can see the underlying statistics histogram. So we will actually show that to you. So let me switch to the customer table here. And then I need to switch to the state column over here. Okay. So here's my statistics histogram. Each of these different values represent all of the different 50 states in the US. And this blue column here actually represents the range, or in this case, the discrete value that was selected. Actually, let me zoom out. I'm going to do the tooltip, and now I can show you that better. So the high range key is Illinois. The quality rows from the histogram, 190,000. So my estimated versus my actual is shown here, right? So, but I can quickly visually see, I can quickly visually see that Illinois got a heck of a lot more data than what we compiled with Alaska. That has nothing. It doesn't even show up on the scale. Had we queried for, say, Massachusetts, my behavior would have been a bit different. Or maybe, for example, if I had compiled this execution plan with Massachusetts as that first value, then I would have a different type of execution plan. Also, if you scroll further to the left, we have a different type of parameters tab inside index analysis that's showing me not only the compile and the runtime value, but the rows that came out of here and the operator that we estimated we would wind up doing. So again, additional information that we manifest to you in here inside index analysis. And index analysis was one of those things where if you haven't spent time with it, I strongly encourage you to spend time with it, because it's what really takes things to the next level. And we'll be talking a little bit more about it, as we go on tonight. But really, there's a lot of cool stuff in here. And having this statistics histogram at your fingertips is really, really powerful. Now, if you're not executing your code or within Plan Explorer itself, and you're bringing things in from Management Studio, like I did in this version 1, then when you jump over to index analysis, you will be greeted with this. You need to get an estimated or an actual plan, because at this point, all we have is the information inside the plan XML, because that's all you dragged in from Management Studio. So you do need to go actively get an estimated or an actual. There is a consequence to this, though. Especially when it comes to statistics. If you're looking at something that happened, maybe you're grabbing an execution plan out of Query Store or something like that, right? We will be grabbing the stats as they are right now. So they may not match the stats as they were 4, 6, 8 hours ago, or whatever, whenever a given execution happened to have occurred. So understand that is one kind of consequence of all of this, but it is a better than nothing. So it is what it is. So understand that isn't, it's a known limitation, until Microsoft starts, including all of the histogram information in the plan XML, which I don't foresee them doing anytime in the near future, because that would be a heck of a lot of info. Okay, let's see. What else did I want to talk about next? No, we talked about that. Talked about that. Oh yeah, missing index recommendations. So let's see. So in this example, we happen to have a missing index recommendation that was generated by the query optimizer. And you see how it's manifested here vertically, right? And if there were other non-clustered indexes, they would be manifested here. But in this case, this table only happens to have this guy here. But one of the things that we happen to have are these visible column checkboxes right here. And usually other is not selected. So let me actually unselect that. So typically this is what you would actually be seeing first and foremost, right? Now I would only be seeing the customer ID and the state, because these are the index columns and or the columns that are used in the query. So if I go ahead and create this missing index, it will just be that one column non-clustered index. But you know what? Maybe I know better. So this might be a case where I might want to click on other and add in additional columns. So you know what? I'm going to grab email as an included column. Maybe I'll do city as an included column. We're doing this against states, so maybe zip code might be my second index key, for example, or something like that, right? So leverage this to kind of play around with your different index definitions. Again, this visible columns checkbox is one of those things that I always glossed over until I'm like, what does this thing do anyway? Oh, hey, wait a minute, here's everything else, right? So make sure that you play around with this, so that'll give you further capabilities to use index analysis as a sandbox to iterate through and adjust your indexes. Remember, you can click on the script indexes button down here. You can make some modifications. If you want to live dangerously, you can click on execute. And I'm going to actually do that right now. And then remember, I can go get actual plan and re-execute that. I don't want to do the entire actual get actual execute plan, so I'm just going to copy out the text, and we'll dump that into the command text here. Let's see, 1, 2. And then I'll just copy that again. Actually, I just need to do a set. Remember, I just applied that missing index recommendation. We'll do this, get actual plan. Now I'm rerunning this guy again. Okay, and now that we've done that. Now, did this actually fix things? Well, no, I still see I happen to have that parameter sniffing issue. And of course I'm going to have that parameter sniffing issue. The reason I kind of like to show that little example is that there are folks out there that say, oh, there's a missing index recommendation. Apply that missing index recommendation. It's going to magically fix everything. No, it's not going to, because again, this is a different kind of root cause for this kind of performance issue, right? So I just kind of wanted to illustrate that. Oh, okay. I have to actually click on a statement, and then we see underlying here. Let me actually show you the reference to the query against the customer table. Where are you hiding? Down here. So now we actually see that the execution plan for that both first and second guy did do an index seek against that missing index that I did create. So we did leverage that missing index. It did help us out, but it didn't really change much. And I can further prove that by looking at the table IO. Oh, hey, by the way, I forgot to look at the table IO of the original statement. This is where I can go back into history once again, right? So let's go back into history. Let me select the right statement down here. And the table IO column down here is basically the output of set statistics IO in a nice table format. We were focused on the customer table here, so we did 15,000 logical reads here in this case. And then let me jump back to version 4, which was the guy that we just executed. Let's look at the customer table once again. 1,200. So we did make a huge improvement here. So still, we at least made some progress by actually, creating a nicer non-clustered index. But this is once again where I'm going to use this as an iterative process. Maybe I'm going to make some other index adjustments or other things like that, because even though it doesn't necessarily fulfill or solve the it doesn't necessarily solve the parameter sniffing issue, I may still look at this and say, oh, hey, while I'm here, I should tune this a little bit and maybe look at this reference to inventory or something like that, and make some adjustments as I'm going through here. Okay. So with that, let me find a different example to also talk a little bit about something else that's inside inside index analysis that's actually quite new. So let's see. I need to find random VIN lookup. Here we go. This guy right here. Okay, let's go to index analysis once again. So this is a store procedure that just does like a single vehicle lookup randomly. And then let's see, I need to go to the inventory table. There we go. And then I will move my little my face. Okay, so we're taking a single value, like a single VIN number. We're just doing like a random kind of lookup type operation here. So up here, if you look at the execution plan against the inventory table, this is a classic case of a seek and a key lookup, because we were below what's called the tipping point. The tipping point in SQL Server is basically the value such that, or the value range such that SQL Server will choose to use a non-clustered index and an additional key lookup operation, because that non-clustered index doesn't fully cover the query, versus tipping over and saying, you know what, forget using that non-clustered index. I'm just going to do a full table scan instead. So we now visualize that tipping point inside Plan Explorer in the statistics histogram, and that's kind of what I want to show you. This is a relatively new feature that's only several months old. So let me readjust my windows once again. Now, hopefully you see why I like to drag index analysis into its own monitor if I possibly can, because there's so much information in here. This thing is quite dense. Okay, so we came in here with one particular VIN number, and this VIN number, because it's a singleton value, the range key is, this random VIN number, right? Well, my range rows is this value here. So, and then the tipping point range, this is the new value. And, so it's somewhere between here. And I don't remember the exact algorithm. Greg Gonzalez actually wrote a really nice blog post talking about this. But I can visually see where it happens to lie, and the fact that, so there's actually the estimated and actual rows are dotted lines, but because it's one, they're actually right here smack at the bottom, well below the tipping point. If, for example, it was a value higher than 1, then you might see that dotted line kind of across like this, and this sloppy little line like that. But you see that it's below the tipping point. Now, if it was above the tipping point, if it looks if the dotted lines are above here, then we'd be looking at a full table scan. We wouldn't be seeing an index seek type operation. So, understand that we have this level of detail that we now manifest to you as well. If you have those, key lookup type operations, see where that tipping point is and see if it's one of these types of scenarios. And again, it'd be a good idea to probably make those non-clustered indexes fully covering if possible. So something else that I just kind of wanted to show off. All right, so cool. Any questions up until this point before we move on to yet another demo?
No questions yet, but let's give a moment to see if anything comes.
All right, cool. So while people while we're giving folks a minute or two, I'm going to resize my windows for this next little demo. And for what it's worth, looking at the time, I think I am, because we have a little bit more flexibility, I think I am going to do these next two demos are what I flag as optional demos. I'm going to do them for you, so we are going to go a little bit long. Hey, if you got to bail out, you got to bail out, no big deal. But I figured, I'll do this extra demo or two for you. Okay. Any questions at this point? Yes, no? I know we got some delay. Okay,
that's looking good.
Cool. All right. So, all the stuff I typically run in demos, because we have limited time, are fairly fast running demos, right? But what if we have that statement that takes forever and just keeps on running? Like this guy here, it's just a select star from a nested view. And if you know me, you know I hate nested views, right? Let me move my window down here. So I'm going to start executing this guy. So one of the cool things that we do is that when you get actual plan is that we will do something called live query profiling, and we can visually show you what's going on and where. So you can actually kind of see what's, where the activity is going and where SQL Server is currently spending its time. So you see the data flow and the data movement in this animation here. If I'm coming down here, it's actually right now, we're just pulling a ton of data from a clustered index scan against the inventory table. And this is something that's, pardon me. This is something that's going to be executing for quite a while here. But, now I can sit here and say, oh, well, this is actually what's going on. I can kind of sit here and watch this thing tick along. And, you can actually see the progress bar up here. I'll do a little zoom it. This is what we believe the progress to be. This is our estimation. So it's obvious to us that, ooh, we have a long way to go here. So this is not cool. So, sometimes if you happen to have those long running statements, you can take advantage of that as well. And, again, this is something that's pretty cool. And then in addition to that, I'm going to stop this now because this is my nemesis, the nested view. We do have a join diagram down here tab that will show you a true breakdown of the underlying tables that are all being referenced here. Notice that this little thing here is basically a self-reference as well. So there's something goofy going on where we're going back on ourselves. But this is the true logical tree of relationships here. Now, this doesn't mean that we're not necessarily going after certain tables multiple times, because that's exactly what's happening in this particular particular example, this is just showing you the relationship or the true logical, the true relationships between all of the different tables, as they are finally just mashed all together. Okay, so make use of that to kind of get a better sense of, hey, if we're doing lots of crazy views, take a quick look at the join diagram. All right, so that was a quick little demo. The next little quick demo that I'm going to do is about my other main nemesis, scalar user-defined functions. So I'm going to dump this into the command text here. So we have this select statement that executes two different user-defined functions, right? I'm going to click on Get Actual Plan. And then let's look at the Results tab up here. And this is pretty cool. I actually see all the discrete executions of each piece of code. That's really awesome. And I see the underlying resource utilization of each different execution of, of everything. So that can be very, very useful when you're executing this piece of code using Get Actual Plan. However, there is a drawback. I'm going to select one of these statements. And unfortunately, we don't have an execution plan for that. Because of the way SQL Server essentially executes things in its own like session, or I don't know what the proper terminology is, but because of the way these statements from the scalar user-defined function are basically executed, we can't get at this information. And coincidentally, you cannot get at this information either inside Management Studio. So if I were to go into Management Studio and execute this code with get actual execution plan, the only thing we'd be getting back, or you would be getting back inside Management Studio even, is this, the outer execution plan. On the other hand, if I click on Get Estimated Plan, now I'm able to manifest not only the execution plan for the parent, but the execution plans for each individual statement inside the scalar user-defined functions. And this behavior is also identical to that of Management Studio as well. Again, some quirk as far as how SQL Server decides to expose this type of information, and it behaves differently when I do Get Estimated versus Get Actual. So one of those, it's again one of those odd quirks that I kind of wanted to point out. The other thing that I wanted to mention, and oh yeah, I can go back in time for this one. Let's see, was it this one or was it this one? Oh wait, no, it was this one. So okay. So I'm going to go back to column chooser, and I'm going to drag in a column called object name. So one thing that will help you when you're troubleshooting this stuff, these statements, where did they come from? With the object name, now I can actually see that. So that at least is one other advantage that we happen to have. Oh, so I see it's this UDF that was executed, then this guy, then this guy, then this guy, and so on and so forth. So I can visually see what's actually all truly happening. So again, there's pros and there's cons. Like I said, we can't get you that underlying execution plan, but we can get you this information. So this is something that can still be very helpful for you to see that, oh, we're doing this iteratively, right? And if you need to prove to a developer who doesn't believe that, scalar user-defined functions go iterative or are executed in an iterative fashion, this is another convenient way that you can show them without having to break out profiler or something like that, right? Okay, so that concludes that brief demo. So let's move on to let's do this demo finally. So the final demo is what I kind of like to talk about as my sort of process as far as diagnosing code and that sort of thing. So I happen to have this store procedure here, get sales history by customer. I'm going to get actual plan here. And my task is to figure out what's going on with this thing. What are some of the headaches that people are that are run, this is a terrible piece of code. It's running poorly and that sort of thing. So okay, so it's done executing now. So typically what I'd like to do is I'll sort by any of the different percentage columns. And by the way, this is where I should explain, at least with estimated CPU cost percentage and estimated IO cost percentage. A lot of people get confused when they see this percentage thing down here. Oh, this statement used 4.6% of CPU? No. What these percentage costs represent is the percentage of the statement's resource utilization for the result set. So really, it's this statement, its CPU utilization. This number equates to 4.6% of everything that was executed, in the entire result set. So, obviously there's more records as you scroll further down. So that's what that percentage means, okay? So that's one of those things that kind of confuses folks. So I wanted to mention that. So I'm going to quickly just, so I'll typically just as a shortcut, I'll slice, I'll do it both by estimated of total percent of total estimated CPU, and then percent of estimated total IO. I'll sort by both of those two different values. Also, I'll make use of the filter just to look at the discrete values that are here. Is there a big outlier here? There's always going to be a 100% because obviously there's that summary store procedure here, right? But is there like a 60 or 70 or something like that that really jumps out to me? So, you think of this as like getting my discrete or my distinct values, right? For what it's worth, we happen to have multiple 0.0s because of rounding. They're actually like it's 0 point tiny numbers, but we round it up visually here, but we don't smash it all together. So that's why that's the case. But in either case, I quickly glance at those. I quickly glance at those. So again, get an assessment of, is there a particular statement that is completely crushing or outweighing everything else? And in this example, there is not. This is a case where there's many statements, and it's really the sum of the problems that are kind of really starting to cause you issues and headaches. And it's this insert statement that's executed, time after time after time here. So what's really going on is this insert statement. Let me just review the text data for you. This is demo code, of course. So we're doing an insert into a temp table, and I have a select statement for a given customer ID, blah, blah, blah. The details are not important. But then there's a union all with an identical select statement underneath it with a second customer ID. And then a third union all, or a second union all with a third select statement with a third customer ID. So basically what this is doing is we have some code ahead of time that grabs 3 random customer IDs, and then in this query inserts them into a temp table. So it's kind of trying to simulate kind of like a pseudo randomized workload here. And by the way, remember that reset sorting option here. I can reset sorting to see this this workflow. So I'm going to reset the sorting. And then here's my insert statement. Here's my select statements to get each of the different random customer IDs. And actually, here's my loop, and here's my underlying looping code. And mind you, you would not be getting this information had you brought this the Plan XML in from Management Studio, because again, these guys, which are not effectively doing anything, some of these guys will not appear in there, right? So again, another advantage to using this as its own perf tuning environment, not necessarily a development environment. Think of it as a perf tuning environment. All right. So here's the problematic piece of code. Let's resort by the estimated cost. So we see that this is something that is executed a whole bunch of times. So even though each execution in of itself is not that high of a percentage, it's something that that does a whole heck of a lot of work. So I'm going to quickly glance over here to the right to see if any of my interesting optional columns have popped up. Right. So let me do that real fast, and I'll resume in. So I see that we have parallelism here. We have a lot of parallel operations, and then there's a good number of key lookups and missing indexes. So I'm like, whenever I see both key lookups and missing index recommendations, that's always a potential opportunity for low-hanging fruit, right? So let's kind of take a quick look at those. I'll typically start out with that. But also when I see parallelism, I'll typically ask myself, the questions of, is this parallelism that we want, or is there any unbalanced parallelism as well? So let's quickly kind of answer some of those. Let me pick one of these guys down here that has a little bit more data. So remember, I can go back down to the plan tree, for example, and kind of get a sense of how many records do we pass around to each of the different threads. 0, 1, 0, 0, 0, 0, 1. So, it's definitely balanced, but these are really tiny numbers. Why did is this really a scenario where it's worth going parallel or not? Hey, wait a minute. So this is where I'm going to now want to dive into top operations and double check, the estimated subtree cost values, right? So let me do that. And let's see. So I'm going to zoom in here. So estimated total subtree cost is 69.8. And so, okay, so it's a higher value than that default of 50. I use quotes around that heavily. But in either case, it's one of those cases where, you know what, do I really want to be doing this or not? Maybe, maybe not. Or is this a case where if this is a piece of code that's executed all the time, do I want to use a query hint to make it not go parallel? Because maybe I don't want this thing to go parallel, right? But again, now I know that it's a relatively speaking low-cost query. So again, do I really want this guy to go parallel or not? And then now I'm going to jump over. So now that we've kind of figured that tidbit out, let's go over to index analysis and let's see if we have any interesting low-hanging fruit with those different missing index recommendations and keylookup operations. The reason, by the way, there's 3 and 6 respectively is that because we have 3 identical select statements that are union together, it's actually essentially been multiplied out. Ooh, this is a good this is a side example that I want to showcase while I'm here. When you're looking at a execution plan and Plan Explorer, sometimes you might see operators that are grayed out. What happened here, Andy? Well, this is actually a case where SQL Server actually was smart enough to skip this step and didn't actually execute it because it saw that, oh, hey, this index seek, I didn't get any data back. So when we brought 0 records back for that, when we got to the nested loop, we didn't have to jump down to this keylook. We got to skip this entirely. And sometimes you'll see entire chains of trees of operations get grayed out, and that's exactly what's happening here. So if you ever see that, that's essentially what happened. So we got to skip some stuff. That's kind of a good thing. All right. So let's see. Oh, okay, cool. I'm already open up on sales history. Let me move my window up here. So this is a case where against the sales history table, I happen to have 2 missing index recommendations here. So I can start kind of playing around with those. And then, we noticed that, they're actually kind of similar to one another. But remember that the missing index recommendations out of the query optimizer are not always that smart. So these are, as you can clearly see, redundant missing index recommendations, because this second missing index recommendation has included columns which will fully cover the first missing index recommendation, right? So I want to completely discard this missing index recommendation. I don't care about it. I should leverage this one. But again, if there were other non-clustered indexes on this table, you would see them here. And then I might see that, oh, hey, I actually have an index that's already very similar to it. Maybe I'll just modify that particular index as well. So, this is a place where I might start playing around with that and or, make that particular change here. Also, the one other thing that we should always be doing is looking to see if you have any warning symbols, on any of your operators or on the root operator. In this case, I happen to do so. And then we look at the underlying warnings and, oh, I have my other best friend, implicit conversions. So this is yet, another example of something else to dive into here. So, but, again, I wanted to kind of give you a sense of what are all the common first things I always kind of check. Where do I typically go? And, this is kind of my workflow, because, each of these different things of like referencing the, the statements in these optional columns that come through here, and then, kind of pursuing down the path of, looking into these, missing index recommendations, these low-hanging fruit. These are all kind of different things that I will typically do. And then if I have the ability to, like, in this example, I would, script the index out, I would make some changes, I would, get another actual plan and see how things change and kind of start iterating through this. Because again, I want to try and use this as a perf tuning environment if I can. Again, please don't play in prod. If you do so, I take no liability. So with that, we've kind of concluded the demos. So let me just kind of wrap up and leave you with a few parting thoughts. And really the parting thoughts, well, again, I already kind of mentioned, the primary parting thought is to, hopefully try and leverage Plan Explorer, leverage the, the command text and, start getting used to using Plan Explorer as that perf tuning environment. You don't necessarily always have to keep jumping back and forth within Management Studio. Hopefully I've been able to show you some really cool ways or new things within Plan Explorer that maybe you've never really delved into before. Explore the different optional columns that you can drag in to see, again, additional levels of detail, and so on and so forth. So hopefully this is something that's been able to help you guys out. Because this is a brand new session, please, please, please give me some feedback. Let me know if this was helpful for you, and if it wasn't helpful for you, please tell me why, and please explain to me how I could potentially improve. My email address is down there, and I would welcome any kind of feedback anyone happens to have. Tweet me publicly, whatever. You're not going to hurt my feelings. Just please give me something constructive that can, again, help me out, because this session is relatively new and has been evolving every single time I've been presenting it. So with that, are there any final questions?
No questions yet. Got several
Sure.
people saying this was an outstanding session. We'll be
Thank you.
spending more time with Plan Explorer.
Cool, good. And for what it's worth, the one thing I always forget to say at the beginning of this, if you've never heard of Planet Explorer, it's a completely free tool. That's the other reason why this is a community session. This is not a vendor or anything like that. Download it for free. We don't even collect your email address, so that's how free it is. No strings attached. You can use it in a corporate environment. We don't care. Just use it. So freer than free. So I always forgot to mention that in either case. But most of y'all know that, I hope.
Excellent. So it looks like no questions, unless somebody is furiously typing away and just trying to get that in the very last moment before we wrap up. Kind of like Indiana Jones sliding under the rock while it's falling. Yep.
Not a problem. I'm happy to hang out for another minute or two and fill the dead air with randomness. So.
Excellent. So thank you so much for presenting for our group tonight. Great session, Andy. A furious compliment.
Well, thank you very much. I appreciate it.
And with that, we are going to wrap up for tonight. Check out meetup.com/trypass for our next sessions. And please do send Andy any feedback that you have. We're going to wrap up. So thanks, everyone, and I'll see you again.
Cool. Thank you again so much. It's been a pleasure, and I hope you all have a good night. Stay safe, stay well. Bye-bye.